Variable geometry turbochargers, VGTs, also known as variable nozzle turbines/VNTs, are a family of turbochargers, usually designed to allow the effective aspect ratio of the turbo to be altered as conditions change. This is done because optimum aspect ratio at low engine speeds is very different from that at high engine speeds. If the aspect ratio is too large, the turbo will fail to create boost at low speeds. If the aspect ratio is too small, the turbo will choke the engine at high speeds, leading to high exhaust manifold pressures, high pumping losses, and ultimately lower power output. By altering the geometry of the turbine housing as the engine accelerates, the turbo's aspect ratio can be maintained at its optimum. Because of this, VGTs have a minimal amount of lag, have a low boost threshold, and are very efficient at higher engine speeds. VGTs do not require a wastegate. VGTs tend to be much more common on diesel engines as the lower exhaust temperatures mean they are less prone to failure. The few early gasoline engine VGTs required significant pre-charge cooling to extend the turbocharger life to reasonable levels, but advances in material technology have improved their resistance to the high temperatures of gasoline engine exhaust, and they have started to appear increasingly in, for example, gasoline engine sports cars. The two most common implementations include a ring of aerodynamically shaped vanes in the turbine housing at the turbine inlet. In general, for light-duty engines, passenger cars, race cars, and light commercial vehicles, the vanes rotate in unison to vary the gas swirl angle and the cross-sectional area. In general, for heavy-duty engines, the vanes do not rotate, but instead the axial width of the inlet is selectively blocked by an axially sliding wall. Either the vanes are selectively covered by a moving slotted shroud or the vanes selectively move versus a stationary slotted shroud. Either way, the area between the tips of the vanes changes, leading to a variable aspect ratio. The vanes are controlled by a membrane vacuum actuator, electric servo actuation, three-phase electric actuation, hydraulic actuator or air actuator using air brake system pressure. The invention introducing the VNT was developed under Garrett, Honeywell, Calder-Lide Signal at the time. Several companies supply the rotating vane type of variable geometry turbocharger, including Garrett, Honeywell, Borg-Warner, and Mitsubishi Heavy Industries, MHI. The rotating vane design is mostly limited to small engines and or to light-duty applications, passenger cars, race cars and light commercial vehicles. Main supplier of the sliding vane type of variable geometry turbocharger is Cummins Turbo Technologies, Holset. One of the first production cars to use these turbos was the Japanese 1988 Honda Legend and used a variable geometry turbo with an integrated water-cooled intercooler installed on its 2.0 liters V6 engine. There was also the limited production, only 500 produced, 1989 Shelby CSX VNT, equipped with a 2.2-liter Chrysler K engine. The Shelby CSX VNT utilized a turbo from Garrett, called the VNT25 because it used the same compressor and shaft as the more common Garrett T25. This type of turbine is called a variable nozzle turbine, VNT. Turbocharger manufacturer Turbocharger uses the term variable area turbine nozzle, VATN, to describe this type of turbine nozzle. Other common terms include variable turbine geometry, VTG, variable geometry turbo, VGT, and variable vane turbine, VVT. In 1991, Fiat puts a VNT in the Chroma's direct injected turbodiesel. The Peugeot 405 T16, launched in 1992, used a Garrett VAT25 variable geometry turbocharger on its 2.0-liter 16-valve turbocharged engine. The 2007 Porsche 911 Turbo has twin VNT turbochargers on its 3.6-liter horizontally opposed 6-cylinder gasoline engine. The Knigsg 1:1, a reference to the car's HP to curb weight ratio of 1:1, launched in 2015, uses twin variable geometry turbochargers on its 5.0-litre V8 engine, allowing it to produce an impressive 1,361 horsepower and become the world's first megacar. VGTs have been used on advanced turbo diesel engines for many years, primarily to compensate for performance loss when the engine is equipped with an EGR. Typically VGTs are only found in OEM applications due to the level of coordination required to keep the vanes in the most optimal position for whatever state the engine is in. However, there are aftermarket VGT control units available, such as the Suproc Technologies Turbo Commander, and some high-end aftermarket engine management systems can control these turbochargers as well.